My name is Damian Clogher. I am a electronic systems engineer at Boeing. I am a graduate student of space resources at the Colorado School of Mines, and I'm a researcher with the Planetary Sunshade Foundation, on whose behalf I am giving this talk. This talk is on the possible synergies between the two concepts of, planetary sunshade and space elevator. The sunshade is a very large-scale space megastructure requiring the use of space resources from the moon and near-Earth asteroids. Um, and a lot of this industry that we might build in space to build a sunshade could also be used for other things, including space elevators. And also, space elevators can help to both set up the industry and also accelerate the process of building a sunshade. So before I get into what a sunshade is exactly, and I will go over it briefly, we should talk about the why we would build a sunshade, and it essentially comes down to the need to reduce Earth's temperature due to climate change because of carbon dioxide in the atmosphere. We could reduce emissions or remove emissions, but have to fully make sure our temperature remains tolerable, it's best to also have the option of reflecting sunlight. Now, there is some controversy around climate change, but generally the controversy is on the exact mechanisms of climate change and not on the fact that the world is warming, which everyone pretty much agrees on. Um, Regardless of why the world is more warming, reflecting sunlight will always cool it down. So the sunshade is useful in a lot of different scenarios, essentially. Um, the sunshade is a sub set of geoengineering or sunlight reflection or solar radiation management. Um, Geoengineering is also controversial, but generally that controversy is centered on reversibility and the fact that you don't want to cool the world too much and end up with the opposite problem. A sunshade is inherently reversible. It's also inherently controllable. The only thing you need to do to control it is tilt the sails, essentially, that a sunshade is made of. So it's very simple to control this, and so it makes it an inherently safe structure. So what a sunshade is it is a swarm of solar sails in orbit between Earth and the Sun to reduce global temperatures simply by blocking sunlight. Only a small portion of sunlight would be blocked, around 1%, and this would cool the world by about 1 degree Celsius. Depending, the exact amount of cooling depends on, what the international community wants and what is allowed there. And so that's a conversation that will have to be had. But that conversation can't really begin unless there is the technology to do this in the first place. The sunshade would be placed at the Sun-Earth Lagrange point 1. Most in this audience are likely familiar with the Lagrange points, but they are essentially points where the forces between two bodies balance out. The L1 point is always directly between the two bodies, and a sunshade placed there would always shade Earth, and therefore that is the most efficient place for a sunshade. Putting it anywhere else requires much more mass to always have something blocking the sun. Technically, it actually would lie at a point closer to the sun than the L1 point that we call L1 prime, because there's also the radiation pressure on the sun from the shades, and that affects the equilibrium. So the fabrication of the sunshade would have to be done in space because it is a very, very massive, well, it's a massive set of objects, not one giant structure. There is no way we would ever launch it all from Earth. That would actually cause more damage than good. So as a result, what we would do instead is we would launch from Earth to set up industry on the moon or near Earth asteroids, and then we would use that to build the sunshade. As I'll go over soon, that industry could be built with a space elevator, and it could also be used to build a space elevator or to expand a space elevator. And so that's why these concepts have the potential to build a positive feedback loop with each other. So how large exactly is a sunshade? It definitely depends on how much light you want to block, and so there's some geometrical calculations that can be done there as to the size of the shade, and then from there, you multiply by the thickness of the aluminum foil, and you get the mass. The mass is generally agreed upon to be around 100 megatons for a significant cooling effect. This would also be built over decades. What would occur is you would have a small industry on the moon that would then be used to build up more industry, and you would also have and you would over time be able to build more and more of these sunshades. So again, this would mostly be built with lunar resources. The only thing here is that the moon doesn't have carbon. So it's useful for the sunshade, which is built of aluminum, and it's useful for electronics in space, which is made of silicon mostly. But it's not so useful for space elevators because space elevators require graphene or carbon nanotubes or similar materials. But fortunately, though, there are carbonaceous asteroids nearby Earth, and these could be used to make space elevators, while also providing materials useful for sunshades as well. Asteroid captures are complicated, and it depends on the exact asteroid and timing and such. But recent research with the Sunshade Foundation has begun leaning toward, and let's pull up the next slide, a heliogyro design. Which works on so the sail is held in place by its own rotation, which means it doesn't need much structure. And this greatly reduces the mass and greatly increases the size of the sail that you can build. And so this could make, and more research is needed on this, but this could make asteroid capture much easier. And so, how sunshade technology can be used for space elevators, one of the most important ways is we could launch one of these heliogyro, or we could launch the material to build one of these heliogyros at the asteroid, out of a part of the asteroid, then bring the rest of the asteroid back. And then from there, the asteroid would most likely, you would use the carbonaceous part to build, the carbon nanotubes for the tether, and then you would use the rest of the counterweight, what ISEC calls the apex anchor. You could also use lunar mass as well for the counterweight. And then one thing that I wanted to include here, there's the concept of an orbital ring, which is essentially a different type of space elevator that doesn't rely on centrifugal force, but relies on essentially the force of a rotating stream of particles that's rotating faster than its orbital velocity, that's then holding a stationary object in place. That requires a very complex electromagnetic coupling with very high relative velocities. But if something like that can be done, that particle stream could be made of, for example, lunar iron. And then the rest of that orbital ring, the tether that hangs down from there to the ground, would be quite similar to a regular space elevator. It would just be much shorter, and therefore could be made of different material, or could be still made of carbon nanotubes for even better performance. And as for how space elevator technology can help sunshades, the main benefit is a lower cost to orbit. So the moon and asteroids are essentially a multiplier. You launch a small factory or fabricators to that body, and then you get 100 or 1,000 times more mass and product off of them. If you can lower the cost of mass to orbit, you can increase the initial mass of your factories, and you can accelerate this process. So a space elevator can help with that. A space elevator can provide free boosting to cell one at certain times. While you probably, if you scaled up space elevators enough, you could launch a sunshade directly from Earth. It's the rocketry that really does the damage, not the launch itself. But launching 100 million tons of a space elevator is probably a long way off. More likely, you would launch certain specialty electronics and such to cell one or to other points in space, and that could be done with a space elevator. And then there's lunar space elevators, which can be made of other materials like, for example, basalt fiber. I am currently researching using basalt fiber to make spin launchers on the moon to launch material into space, but it's possible that similar technology could be used for a long space elevator like tether from the moon. And so essentially then the idea here is just to say that these concepts can build off of one another. You can use Sunshade Tech to build a elevator faster, or to multiply the amount of elevators you have, and you can use elevators to greatly increase your capabilities in space and allow you to build sunshades easier. For example, you could use the elevator to launch a craft to an asteroid, then capture that asteroid and bring it back to make another space elevator, or widen your elevator, and then use that to launch more asteroid mining craft, and so on and so forth. So if anyone wants to reach out offline and discuss any possible research opportunity, or possible collaborations or some such, I would be happy to talk to anyone about that. And thank you for your time.
Yeah. When you mentioned a spin launch, did you literally mean like spin launch like the company, or are you talking about a different mechanism?
I should probably use the term, well, I wanted to say centrifugal launch, but then that gets confused with the space elevator itself. Essentially a very similar concept, but not directly affiliated with spin launch, the company itself.
Okay. But maybe loosely conceptually related.
Right, the same idea. A tether that rotates very
Okay.
quickly and then releases an object
Okay.
from its end, and yeah.
All right.
Okay, Kai, I think you had your hand up.
Yeah, I'm debating about asking my question.
Okay, we'll go to Jim. Jim?
Yeah, please do.
Why use a carbonaceous asteroid when Earth itself is abundant carbon or graphene? Not graphene, but graphite. You got abundant supplies of graphite, and you've got coal that you could extract the purify for graphene production, and possibly even CO2. A little more energy input to make the separate the carbon.
I think the idea would generally be that this would be the beginning. I know that it is possible to build a small space elevator. It may be useful if an asteroid could be found in time to capture an asteroid first. I think the larger benefit would probably be from the counterweight mass, which you might not want. An early space elevator would have a small throughput, and so you might not want to use that throughput to build your counterweight. You might want to get that counterweight from space so that you can use that initial throughput for more useful things for the elevator.
Matthew?
Hi, I have a quick question. Has there been any thought into creating a loop to create a electromagnetic shade?
Yes. I think what you're talking about is creating an artificial magnetic shield. Yes, there has been thought put into that. That could be useful for a lot of different things, especially as we expand outward into space, and need more shielding for astronauts and such.
Pete?
I've always wondered about total mass lifted off of the Earth for sunshades. I was working with the University of Colorado up there for years, 20, 30 years now on sunshades. I noticed you got down to 7.4 million tons from the bigger numbers. Is that 7.4 million tons lifting off the Earth, or is that the combination of the stuff on the moon and the stuff you lift off Earth?
So I think it was actually 74 million. And it
74
would
million,
come, the bulk of it would come from the moon. We estimate now that probably 99.9 to 99.95% could ultimately come from the moon. We would shoot for certainly at least 99% coming from either the moon or asteroids.
Do you take into account all the equipment you got to get up to the moon?
Yes.
Oh, okay. Thank you.
Okay, Eric. You're muted, Eric.
Yes, I am muted. Sorry. Thanks for your talk, Damian. That's a great concept. My question is kind of on the life cycle of the expected life cycle of the sunshade elements. Do you have a sense for how long, what their lifetime would be, and how much effort it would be to replace them over time as needed?
Right. It should not be much effort to replace them, as they would just be replaced by the same apparatus you used to build in the first place. As far as life cycle goes, it has been a question, and there's been some very varied estimates. There are several things that can go wrong, and without getting into too much detail, micrometeorites are not that much of an issue. Sunshades could survive that for many thousands of years. Mechanical or electronic failure is more likely. And in that case, the sunshade would be, that element would be retired by moving it closer to the sun and putting it in graveyard orbit, and then another one would just come along and replace it. Exact time frames for that, it's hard to say. But as long as it was being, as long as they weren't being destroyed faster than we could build them, it shouldn't be an issue. And I do not see how that would be the case. So it should not be much of a problem.